Electricity is incredible. It's a fundamental force of nature, a silent workhorse that powers our modern world. From the moment we wake up to the time we go to sleep, electricity is constantly at our service, making our lives easier, more comfortable, and more productive. With a simple flip of a switch, you light up a room, banishing darkness and creating a welcoming space. It's a seemingly small action, but it represents the immense power we wield with electricity. Think about the convenience instant illumination at your fingertips. Electricity powers your devices, keeping you connected to the world, entertained, and informed. From smartphones and tablets to laptops and gaming consoles, our lives are increasingly reliant on these gadgets, all of which depend on a steady flow of electrical power, and it keeps food fresh, preserving vital resources and preventing spoilage. Imagine a world without refrigeration. The impact on food storage and distribution would be enormous. Electricity allows us to keep food safe and accessible, reducing waste and ensuring a constant supply of nourishment. It's like an invisible river of energy flowing silently through our homes, a network of wires and circuits working tirelessly behind the scenes. We often take it for granted, but this intricate system is essential to our daily lives. Electricity is powering nearly everything we do, from the mundane to the extraordinary. It's the backbone of our modern society, enabling countless activities and innovations that were once unimaginable. But this powerful force must be handled with care. Electricity, while incredibly useful, can also be dangerous if not treated with respect. If it escapes its intended path, it can damage gadgets, cause serious injuries, or even ignite devastating fires. A short circuit or an overloaded outlet can quickly escalate into a dangerous situation. That's why we rely on safety devices to keep electricity under control, preventing accidents and protecting our homes and families. These devices are designed to detect and interrupt dangerous electrical flows, minimizing the risk of harm. These unsung heroes work silently, often unnoticed, to protect our homes and workplaces from electrical hazards. They are the guardians of our electrical systems, constantly monitoring for potential problems. Today we'll pull back the curtain on one of the most important of these safety devices, a critical component in every modern electrical system. It's the circuit breaker. And we'll explore its special feature, the shunt trip. Circuit breakers are our first line of defense against electrical overloads and short circuits. They are the gatekeepers of our electrical systems, standing ready to protect us from harm. They're ready to act at the first sign of trouble, instantly interrupting the flow of electricity to prevent damage and injury. We'll see how they protect us from electrical mishaps, preventing fires, protecting our appliances, and safeguarding our lives, and how a simple command can shut down power from a distance, providing an extra layer of safety and control. So get ready to dive into the electrifying world of circuit protection, where we'll uncover the secrets of these essential safety devices. Science is the key to understanding the world around us, and it provides the foundation for the technologies that keep us safe and comfortable. And today, we're unlocking a big one. We're going to explore the science behind circuit breakers and shunt trips, revealing the ingenious engineering that makes them so effective. Let's get started on this journey of discovery and learn how these vital components work to protect us every day. Let's talk about something vital to every modern home, the circuit breaker. But what exactly a circuit breaker? It's a question many homeowners might not immediately know the answer to, but understanding it is crucial for your safety and the well-being of your home's electrical system. Think of it as a smart valve, not for water, but for electricity. It's a gatekeeper, carefully controlling the flow of electrical current throughout your house. This intelligent device is constantly monitoring the electrical flow in your home's wiring, acting as a vigilant sentry against potential dangers. It's always on the lookout, ensuring everything runs smoothly and safely. Now, imagine a situation where too much electrical current surges through your system, perhaps due to a short circuit, where wires accidentally connect, creating a sudden and massive flow of electricity. Or consider an overloaded outlet, where you're drawing too much power from a single point. In these critical moments, the breaker steps in to stop it, preventing potential hazards like overheating, electrical fires, and damage to your appliances. But how does it actually work? Inside a typical breaker, you'll find a bimetallic strip. When excessive current flows, this strip heats up. As it heats, it bends due to the different expansion rates of the two metals bonded together. Alternatively, some breakers use a magnetic field. In this design, a surge of current creates a strong magnetic field that pulls a lever. Either way, whether it's the bending strip or the magnetic force, the result is the same. The mechanism trips the switch, instantly cutting off the power to the affected circuit. The thermal method, with its bimetallic strip, is particularly effective at handling slow, gradual overloads, like when you're consistently drawing too much power over an extended period. On the other hand, the magnetic method is incredibly fast, reacting almost instantaneously to sudden surges, such as those caused by lightning strikes or sudden equipment failures. Think of it like having two security guards, each with a specialized skill set, watching for different kinds of dangers. One is patient and observant, while the other is quick and reactive. When a breaker trips, you'll notice that the switch moves to the off position, clearly indicating that a problem has occurred and the circuit has been interrupted. This simple action is crucial, as it's actively protecting you, your family, and your entire home from potential electrical hazards. Before you can restore power, it's essential to identify and fix the underlying problem that caused the breaker to trip in the first place. Once the issue is resolved, you can safely reset the breaker by switching it back to the on position, restoring power to the circuit. Unlike the old-fashioned fuses that had to be replaced every time they blew, circuit breakers are reusable, offering a more convenient and reliable solution. They're always on duty, tirelessly monitoring your electrical system around the clock, providing continuous protection. Simple in concept, incredibly effective in practice, and absolutely essential for modern electrical safety. That's the brilliance of circuit breakers, a testament to clever electrical engineering. They're the silent guardians of your home's electricity, working tirelessly behind the scenes to keep you safe. And they never sleep, ensuring your electrical system is protected day in and day out. Now imagine you could trip your circuit breaker remotely even without an overload. That's what a shunt trip does. It's a remote control for your breaker. It listens for a specific electrical signal, not for overloads. Why? Sometimes the danger isn't electrical, like a fire or overheating machinery. A shunt trip lets you cut power instantly from afar, preventing bigger problems. The shunt trip coil creates a separate circuit. When signaled, it trips the breaker. It's an extra layer of control, turning a reactive device into a proactive one. The breaker still protects against overloads, but now you can command it too. It's like giving your security guard a walkie-talkie for emergencies. That's smart, safe, and seriously cool. Seriously. The magic behind the shunt trip is electromagnetism. Inside, a coil of wire waits for a signal. No current flows until needed. When activated, a voltage pulse energizes the coil, creating a magnetic field. This field moves a plunger or lever, triggering the breaker to open. The process is nearly instant: signal, magnet, mechanical action, power off. It's a direct chain. Electrical signal to magnetic force to mechanical movement. The shunt trip uses a small signal to control a powerful switch. Simple, elegant, and effective. That's how remote control meets electrical safety. Science in action. Where do shunt trips shine? In places where safety is critical. In fire alarm systems, they shut down ventilation and elevators to prevent hazards. In factories, emergency stop buttons send signals to shunt trips, instantly cutting power to dangerous machines. Data centers use them to power down equipment before fire suppression systems activate, protecting both people and technology. Smart buildings use shunt trips for energy management, turning off non-essential circuits with a single command. They can even respond to water leaks, cutting power to prevent electrical hazards. Shunt trips make buildings safer, smarter, and more efficient. They're the silent responders in emergencies. Wherever quick remote power control is needed, shunt trips are there. They're essential for modern safety. The possibilities are endless. Installing a shunt trip is serious business. It's not a task to be taken lightly, as it involves working with high-voltage electricity and critical safety systems. The consequences of improper installation can be severe, leading to equipment damage, personal injury, or even fire. This type of work is strictly for qualified electricians. These professionals have undergone extensive training and possess the necessary expertise to handle electrical systems safely and effectively. They understand the intricacies of electrical codes, safety procedures, and the proper techniques for installing and maintaining shunt trips. It means working inside the electrical panel, a potentially hazardous environment filled with live wires and sensitive components. Electricians must be meticulous and precise in their work, taking every precaution to avoid accidental contact with energized parts. This requires following safety procedures to the letter. This includes wearing appropriate personal protective equipment, PPE, such as safety glasses and gloves, and implementing lockout-tagout procedures to de-energize the circuit before commencing work. A comprehensive safety checklist should be followed to ensure that all necessary precautions are taken. The shunt trip must match the breaker model. Compatibility is key to ensuring proper operation and preventing damage to the electrical system. Refer to the manufacturer's specifications and compatibility charts to verify that the shunt trip is designed to work with the specific circuit breaker being used. It must be mounted precisely, following the manufacturer's instructions carefully. Proper alignment and secure mounting are essential for reliable performance. Any misalignment or loose connections can compromise the shunt trip's ability to function correctly in an emergency. Control wires are run from the shunt trip, acting as the communication pathway between the trip mechanism and the external control devices. These wires connect to remote buttons or alarm systems, allowing for the circuit breaker to be tripped from a distance in case of an emergency. This remote tripping capability is crucial for quickly shutting down power to equipment or areas where a hazard is detected. These wires must be protected in conduit. Conduit provides a physical barrier against damage from impact, moisture, and other environmental factors, ensuring the integrity of the control wiring. National and local codes dictate every detail, ensuring consistent safety standards across all installations. These codes cover everything from wire gauge and insulation type to conduit fill capacity and grounding requirements. This includes everything from wiring to labeling. Proper labeling is essential for identifying circuits and components, facilitating maintenance and troubleshooting. Clear and accurate labels help prevent accidental disconnections or incorrect wiring modifications. The control circuit's power source must be reliable, providing a consistent voltage supply to the shunt trip mechanism. It's often independent from the main system. This ensures that the shunt trip will function even if the main power supply is interrupted, providing an extra layer of safety. After installation, electricians rigorously test the system, verifying that all connections are secure and that the shunt trip is functioning as intended. They simulate emergencies to ensure the breaker trips instantly and only as intended. This testing process involves activating the remote buttons or alarm systems to confirm that the shunt trip responds correctly and shuts down the circuit breaker without delay. This commissioning process is critical for safety, ensuring that the shunt trip system is ready to protect people and equipment in the event of an emergency. Proper installation turns a clever device designed to enhance electrical safety into a life-saving system, providing reliable protection against electrical hazards. Never DIY. Electrical work is inherently dangerous, and attempting to install a shunt trip without the proper training and experience can have serious consequences. Always leave it to the pros. Hiring a qualified electrician ensures that the job is done safely, correctly, and in compliance with all applicable codes and regulations. Safety first, always. Prioritizing safety in all electrical work is essential for protecting lives and preventing accidents. Even the best systems can have hiccups. If your shunt trip isn't working, start with the basics. Check for nuisance tripping or failure to trip. Loose wires or faulty buttons can send false signals. A dead control circuit means no trip at all. Electricians use multimeters to check voltage at the shunt trip coil. Sometimes long or thin wires cause voltage drop, enough to stop the coil from working. The coil itself can burn out if misused. Most issues are solved by careful inspection and testing. Troubleshooting is about eliminating possibilities step by step. Always follow safety procedures. Science and caution go hand in hand. In today's smart buildings, shunt trips are more important than ever. They're integrated into building management systems, responding automatically to emergencies or energy needs. A central computer can cut power to specific areas instantly, preventing damage or saving energy. During peak demand, shunt trips help manage loads, reducing costs and strain on the grid. They bridge the gap between data and power, letting low-voltage signals control high-power circuits. Engineers now design systems where fire, security, and power all communicate. Shunt trips are the key to this integration. As buildings get smarter, these devices make them safer and more efficient. The future is electric and intelligent. Shunt trips are leading the way. Let's recap: electricity powers our world and circuit breakers keep us safe. The shunt trip is the sidekick, giving us remote control over safety. With a simple signal, it can trip a breaker instantly, protecting people, property, and technology. We've seen its role in emergencies, factories, and smart buildings. Proper installation and testing are vital. These systems must work flawlessly. The shunt trip is a perfect example of science in action. A tiny coil with a huge impact. It turns a reactive device into a proactive safety tool. Next time you see an emergency stop button, think of the shunt trip ready to act. It's small, but it saves lives and energy. Now that's seriously cool science.